All right, so for question 6 here, or it's the second part of the odds video here for question 6, I've already asked you to try some of these questions here. Here's asking you for what are the odds against each of the events happening when they give you the probability that the event will happen. So they're giving you the probability in favor. They want to know what's the odds against. So first of all, maybe I want to figure out, because to figure out probability, sorry, this thing jumped around on me there. Let's go back down where we were. Okay. To figure out figure out the odds, because what the odds are going to be, they're going to be, this is against, what's the probability of it not happening versus what's the probability of it actually happening. So I want to know what's the probability of this not happening to start off with. Well, what we know about percentages, and I think I talked about it in the previous video, maybe not, is that if I add the probability of what happens to the probability of not happening, if I add those two together, I should get 100% of my answers. Which is, if it doesn't happen, then it has to happen the other direction. So these two have to add up to 100%. So if I know that 35% is it happening, then if I subtract the 35 from 100, so I would go, if I want to find out what's not happening here, I'd go 100%, and I minus the probability of it happening. Sorry, no, get rid of that. There you go. So I got minus the 35, so I get 65%. So the odds happening are 65 to 35. Against, sorry, because this is the against one over here. This one over here, if I want to know the probability of it not happening, that's 90%, because these had to add up to 100. You could say my 100 is like the sample space here. So it's a 90 to 10 ratio. Now, for both of these, I should reduce them down to better odds, or better numbers here. So this one here reduces down to 13 over 7. Now to do that, just pull out your calculator. You just go 65 divided by 35, go math, enter, enter, and then you get your two new numbers, 13 over 7. So I just put 13 to 7 there. This one here, I'm just going to divide both these by 10 and get 9 to 1. And my last one here, probability not happening here is 15%. Put down 15 there. So it's a 15 to 85. Sorry about that. A 15 to 85. I'm going to reduce that down to 3 to 17 odds there. Okay. For the next one here, I want to know what's the probability in favor of having a baby with blue eyes, and what's the odds, or sorry, not what the odds, but the odds in favor and what the odds against. So you can use the same logic that we had up there. Two brown-eyed people are told that a 25% chance they'll have blue eyes. So that's the chances of it happening. The chances of it not happening is going to be 75%, because these are going to have to add up to 100%. So my odds in favor, so if I want to put this in favor, I'm going to have 25 to 75 odds. I'm going to just reduce that down. Let's reduce that down to 1 to 3, and then against, I'm going to just flip it around and be a 3 to 1 odds against. Okay. Earbuds are on sale, Best Buy. 7 times they were on sale. They were stock only 3 times. So what are the odds in favor that they're going to be in stock? Well, I know that the number that they're in favor is 3. The number that they were out of stock, which is not in stock here because out of the 7 times, there were 4, because 7 is my sample space here. I have 7 trials. So that is going to be a 3 to 4 odds that they're going to be in stock this time. Odds against, you just flip them around. So 4 to 3 odds. So this is against here. So this would be the number against compared to the number to. So very key is that the against, you're going to put that on this side over here, not the favorable outcomes, but the non-favorable outcomes. Okay, so we have two students here. They're going to be playing, or they created a charity games here, one called BIM and one called ZAP. They both have different odds. So BIM has an odds of 5 to 2, while ZAP has an odds of 7 to 3. It says, which game would you play? So I'm thinking that which game have the more favorable outcomes for you, for the person that's playing the game, not for the people in the charity. So to figure that out, it's probably best if you want to try to find the probability of both the games. And then we're just going to compare those two probabilities. So these are the odds against. So I'm just going to find out the probability against the probability of you losing this game, or maybe the probability, let's go with the probability of you winning this game. So I want to go over here and say, okay, here's the 2. This is the chances of winning, and this is the chance or the number of times you lose. Okay, this is against the odds against. So you're losing 5 times, so you're winning 2. So that means you're losing 2 out of 7 times, right? So remember, to find the total sample space when you're doing probability in your odds, you add the 2 sides. I'm just going to divide the numbers because sometimes it's hard to see fractions, because I'll show what it looks like. In this case over here, I'm losing 3 out of the 10 times. This one's pretty easy. This is 0.3. But it's hard to see what number this is until I put it into a fraction or into a decimal, sorry. So I look at these 2 numbers and I say, okay, this is in favor. Me winning this game, I have about 28 to 29% chance of winning this game. Over here, I have a 30% chance of winning this game. So which game should I play? I should play, if I want at least a chance to win, should play, or a better chance to win, I should play ZAP. Right? It's like a 1% chance better. But that's fine. Here's a couple of different questions here that you might see on a test or a quiz or something. Actually, you might see any one of these kind of questions on a test or a quiz. These are just more common ones. These ones are developed by high-ups and people in higher pay grades than I am. Okay, so I'm looking at this one here. The ratings for the movie Butterfly Dreaming indicate that 45% are male. I just wanted to write here that the viewers, 55% are female, because that might be useful. You can see that in this case. What are the odds in favor of this person being in favor of being a female? So I wanted to know that percentage, because 55 of 100 people, if you think percentages as being 100 people, are going to be female, and 45 are going to be male. So this is in favor. This is a favorable outcome here. Okay. That doesn't really match any of these numbers because they've reduced them down. So you take out your calculator, you go 55 divided by 45, math, enter, and you're going to get 11 to 9 for that one. What are the odds against this person being 45 or younger? So they got a lot of numbers here. You got 10, 15, or sorry, 10, 20, and 20. That adds up to 50, and the other 50 are older than 45. So I want to know against this person being younger than 45. So against being 40, that would be greater than 45. So over here I have a 50% of the people are older than 45, which makes 50% of the people younger than 45. So my odds are 1 to 1. There's a 50% chance I'll either pick one or the other. So that answers up that. And next time we're going to be talking about probability using counting methods, permutations, and combinations. So we're going back a few chapters here, and we're going to solve some questions like that. All right, I'll see you in the next video.